Hello class and welcome to today's lesson on 5.2 dealing with perpendicular and angle bisectors. So today's goal is to use properties of perpendicular and angle bisectors to find lengths. Our central question is then, how do the properties of perpendicular and angle bisectors help us find missing lengths? So to start is just some review here. Right, we've talked about these terms before in class. Right, what is a perpendicular bisector? Right, it's a line that is both perpendicular to the given line and it bisects it. Right, perpendicular to the line and it bisects it. So looking here, right, if we're looking at something, what it means to be a perpendicular bisector, notice we have a 90-degree angle, and then it bisects that line. So what we're going to do now is try to figure out, okay, well, what does that tell us? What information can we get from knowing that we have a perpendicular bisector? And that's what this next theorem is all about. Again, of course, with all videos here, if you need to pause it to slow down, I'm going to go quickly through these theorems. If you need to pause it to write it down, please do. So our first one, if a point is on the perpendicular bisector, notice like this point C, then it is equidistant, right? So we got to know what that word is, right? Equal distance away from the endpoints on the segment. So notice here, point C is equidistant from those two endpoints. Equidistant from those two endpoints. So again, if you need to pause it, please do. So now we have the converse of this, right? The converse of this theorem is just, right, if P then Q, we're now going to switch it to if Q then P. So right, if a point is equidistant from an endpoint, then it is on the perpendicular bisector. So notice here, point C is equidistant from the endpoints. Well, then that tells us it is on the perpendicular bisector of that segment. So again, converse there is also true. So now using both these theorems, again, if we need to pause it, please do. So looking here, right, we have this picture. What these theorems are getting at is that if we have a perpendicular bisector to segment BC, that means any point on that, whether it be point D or whether it be point A, right, or any points in between or outside of these, that point is going to be equidistant to both point B and point C, because those are the endpoints. So right, it's equidistant to both of those. So now how can we use that to help us solve problems? Right, if we look at this first example, we have a perpendicular bisector, right? Perpendicular and it bisects that segment. Well, that's telling us, what our theorem is telling us is that then, hey, okay, these segments are congruent to one another. They're equidistant. So that means we can set them equal. All right, we set them equal to one another. We solve, do this fairly quickly here. We get -1 plus 7 is 6. 5 minus 3 is 2. For an answer of n equals 3. And now be careful. This is similar to our homework problems, things like that. Sometimes we have to then plug it in, take one step further, and we should get an answer of 8. Should get an answer of 8. So we have another example on the next page here. Again, we have perpendicular bisector. So that tells us, hey, these two segments are equal. So we set them equal and then solve. End up getting 10 is equal to 2x. X is equal to 5. But again, we got to plug it in. And we find the measurement to equal 20. So again, if you feel like I'm going too fast, please just pause the video. Right, take your time through it. So now using the converse, right? Using the converse of the perpendicular bisector theorem. Right, this says, is C on the perpendicular bisector? We're trying to figure out, is that on the perpendicular bisector of AB? Well, all we have to look for is, are these two segments, right, CA and CB, are they equidistant or are they equal to each other? And right, if we look here, we have one at 11 and one at 10. They are not equidistant, so is C on the perpendicular bisector? That answer would be